Great. So I thought I'd get started with a description of what is blockchain in general. Now, I know this is a Seattle blockchain meetup, and so we're all probably reasonably familiar with it, but I figured I'd go over the basics. There are some things that are maybe a little more subtle in some of these things. So blockchain, as the name implies, consists of blocks of transactions. So the notable bit there is it is not individual transactions that are put together, but it is blocks of transactions that are composed together. These blocks, they contain reference to previous blocks, hence the chain in blockchain. So a block of transactions will have a reference to a previous block that came before it. This is what makes it a blockchain. The reference to the previous block includes cryptographic hashing of what the previous block is. So that cryptographic hashing is commonly used as proof of work in Ethereum, for example, as a way for securing the process and making sure that it can't be broken. That hashing can be based on a number of different algorithms and a number of different ways of doing the hashing. Blockchain is commonly used as a ledger. So in the case of both Bitcoin and Ethereum, blockchain is used as a ledger for the balance for the relevant cryptocurrencies that are associated there. So in the Bitcoin blockchain, it's the Bitcoin cryptocurrency that's being used as a ledger there, and Ethereum, it's the Ether cryptocurrency that's being used there. What's worth noting is that ledger is not inherent to the nature of blockchain, but it is one of the things that's commonly used in public blockchain implementations. So the usage of the reference to the previous block and the hashing adds security. And this is one of the primary reasons why we're all really interested in blockchain, is that the security that blockchain brings to things is really sort of innovative in the field. And a final point I wanted to make here is that blockchain is deferred. That means that when we're using blockchain, we're achieving eventual consistency with our transactions. And this is inherent to the idea of blockchain because the transactions that are being presented for a blockchain are eventually created into a block. That block is guaranteed to be consistent with the nature of the transactions that are built into it, but it's only at that block creation time those transactions become consistent with the remainder of the blockchain. And this is an important topic. I'll touch on it again. Could you go next slide? So I figured I'd also talk about what blockchain is not, because it's particularly relevant here. Blockchain is not cryptocurrency. They are commonly paired, but blockchains are not necessarily inherently about cryptocurrencies. Cryptocurrencies are commonly implemented on blockchain, but blockchains do not have to have a cryptocurrency associated with them. Blockchain is not necessarily distributed. And in the case of most public blockchains that we're familiar with, Bitcoin, Ethereum, etc., it is, but that is not necessarily the way it always works. It does not need to be distributed to be a blockchain. Blockchain is not necessarily immutable. That comes back to the idea that when it's not distributed, you may be in a situation where the chain may be mutable in some ways. That's kind of important. It's also worth noting that the code on the blockchain is not necessarily immutable, although it is in the case of Ethereum. And as someone who's worked with Ethereum in the past, that's really annoying to have to work with immutable code on the blockchain. It causes all sorts of problems. Blockchain is not necessarily public or private. Again, the idea of composing your transactions into blocks, having references from one block to another, those transactions, those blocks, they don't necessarily need to be on a public net. They also don't necessarily need to be in a private net. So you can do both or either, or a hybrid, in fact. And notably, blockchain does not provide immediate consistency. As mentioned previously, this is one of the important distinctions between blockchain and other database type solutions. So a typical thing you achieve with SQL databases is you're looking for immediate consistency. So the transactions you submit should remain consistent with the database, and the database will provide you responses that are consistent with those transactions immediately. That's not the case in blockchain. And I'm mentioning this twice now in 2 slides because it comes up later in the presentation. Next slide, please. Perfect, thank you. So there are various flavors of blockchain. There are public, and as mentioned, we have Ethereum, it's a public blockchain. We have Bitcoin, also a public blockchain. There's private blockchain. So Hyperledger is an instance of a private blockchain, and Dragonchain is also an instance of a private blockchain. And then there are hybrid blockchains. And hybrid, in terms of our talk here, hybrid refers to a combination of public and private functionality on blockchain. So in our case, Dragonchain is a hybrid blockchain. There are also other hybrid blockchains. I'm not going to talk about them because I'm here to talk about Dragonchain and hybrid blockchain. Next slide, please. All right. So public blockchain. The features of public blockchain include public, specifically non-permissioned enrollment. So the idea, and we are all familiar with this from both Bitcoin and Ethereum, is that anyone can download the software required to run a node. They can synchronize that software up with all the blockchain data that's existing out there, and they can be running a node. You can do it today on Parity. You can do it today on Bitcoin. It's public. Anyone can get that data. One of the things that's important about that is the entire chain of data that you're downloading then is public. That's very important and worth noting. Also, public blockchain, generally, it's in wide distribution. So public blockchain, because of its publicity, anyone can download it, and you get distribution across not just a geographic region, but across disparate geographic regions, across all sorts of areas. A lot of the value in public blockchain, what makes successful public blockchains, is they achieve wide distribution. High visibility as well comes in with public blockchain. So any transactions you put on the public blockchain will be visible to anyone who is pulling down those transactions, those blocks in the chain. They can see everything that's there. That's really important. There is deep security in public blockchain. This comes from the fact that there are hundreds, thousands, millions potentially of distributed copies of the same blockchain of data, and that distributed nature makes it hard to attempt to falsify any data by modifying any local copies of a blockchain and passing it off as the honest truth. That's very hard to do. If I were to say to this room that that door is blue and everyone else says no, it's brown, it's hard for me to pull that one off. Same thing with public blockchain. When everyone here shares the same view on reality, then it's very hard to falsify that reality in any way. Some of the concerns with public blockchain that come are throughput. So the throughput for a public blockchain in general, and I'm a little bit generalizing here, but this is generally true, with things like Ethereum. So on public blockchains like Ethereum or Bitcoin, the transactions are presented to the blockchain network. The nodes then pick up the transaction and they attempt to mine those transactions by finding a cryptographic hash that meets a certain difficulty criteria that they can then create a new block with that cryptographic hash, a new block with the previous block's cryptographic hash in it, and then they add that to the chain. So the issue is all of the miners are working on doing the exact same thing. Effectively, that means in the case of public blockchain, Ethereum, Bitcoin, etc., if we have 100 people working on the same thing, then 99 of those 100 people's efforts is wasted. It's just basically going down the drain. You're attempting to mine something. One person hits the jackpot, they get some Bitcoin, they get some Ether, and everyone else goes, ah, darn, I'm going to have to try again. It's not, for throughput purposes, it means that the ability for the public blockchain to be mined and to increase and to put new transactions on the blockchain depends upon roughly the average ability of any one member who's contributing to the blockchain. And that means that instead of having 100 times the possibility of what's going on, we have basically just the average of what everyone's possibility is. It's not great. Privacy. So privacy in public blockchain is problematic because it's public. You're putting your information out there for everyone to do things with. By its very nature, everyone gets to see that information. Everyone gets to see what those transactions are. If anyone here hasn't done it, I highly recommend spending a couple of hours just exploring Ethereum, etherscan.io. Find a contract that you're interested in, and you can see who's been donating to that contract and what the distributions have been, and it's interesting, genuinely interesting to sort of see, oh, all of these transactions are public. There are some proposed solutions, I'll mention as a side note, to privacy on public blockchains. So the ZK Snark, ZK Stark stuff about putting in place private but publicly verifiable transactions and information. It's all brain-bendingly complex and still not completely well proven out. If you look into it, I'd recommend ibuprofen, honestly, for the eventual headache, because it will happen. The other bit with public blockchain that we get, one of the other bits, is we have limited complexity. And we talked again, it goes to the throughput question. So the functionality is the average, not the sum total, of what everyone who's working on the blockchain can do. And that means that the complexity of what can be computed on public blockchain, in the case of Ethereum in particular, where you have a Turing-complete machine that's operating in the EVM, there's a very limited complexity in what you can do. So you can't do certain things with public blockchain by its distributed and horizontally based nature that you could otherwise. Efficiency, which we touched on this earlier. So the efficiency is if everyone's working on the same thing and one person gets it, then everyone else's efforts are basically for naught. Not terribly efficient. Limited external interactivity. This is reasonably common with public blockchains, Ethereum, for example. So when you put a transaction onto the Ethereum blockchain, that transaction can interact with the Ethereum virtual machine and nothing else. It can interact with nothing else. And in fact, it can't even interact with some things that are on the Ethereum virtual machine. So events, for example, are actually designed in Ethereum as being available for external viewers, but not for internal viewers on the block. So a contract that attempts to put an event on the blockchain for, say, a distribution can't actually see the events that it's actually put on the blockchain. It's kind of interesting. And the example that I've been using commonly is Ethereum. I think it's one everyone's probably most familiar with. It's probably the best example of a public blockchain out there right now, in my opinion. Okay, then we go on to private blockchain, complete other side of the equation. So private blockchain is, as you can probably tell from the name, it's high privacy because it exists in a private environment. It's not available to the public. There is high security in private blockchain. That high security comes not from the way public blockchain obtains its high security, which is that everyone has a copy of the same thing. But in private blockchain, the high security is obtained through limited access. So you can't see the contents of my wallet. That's how I keep it private, and that's very effective. There is roughly unbounded complexity in private blockchain. So because there are less of the efficiency concerns going on with private blockchain, because you don't have everyone doing the same thing, there is the ability to have much higher efficiency, bullet point, and unbounded complexity. You can do much more complex things with private blockchain. An example of the types of things that would be viable with private blockchain that wouldn't be viable with public blockchain would be things like machine learning. So machine learning is complex on the data side going in. It would be very hard, if not almost impossible, to implement that on public blockchain. But on private blockchain, because your complexity is effectively unbounded, there's not a ton of difficulty with putting that in place. There's also an ease of access to blockchain external resources. So because you're not running in, for example, in Ethereum, in the Ethereum virtual machine, in the private blockchain, you can say, oh, I want to look up what a current stock quote is for IBM, for example. And you can just go out to the NASDAQ site and find out what the quote is for IBM. So in the private space, because you're in a private arena running private code, you can do all these types of things. You can easily integrate with external resources. The concerns with private blockchain. So there are high trust requirements for anyone interacting with a private blockchain. You have to basically trust that whoever is running this private blockchain is keeping this information secure. It is private. So that's an obvious point of concern. There's a single or small point of failure. It's possible to run private blockchains in a distributed manner and still keep them private, so you can have them running across different data centers, still be keeping them private. But your point of failure is much smaller and therefore more vulnerable than with public blockchain. Public blockchain, there's just too many people doing it to be able to effectively suppress it. With private blockchain, that's not necessarily the case. So one example of a private blockchain would be Hyperledger, as we know of it nowadays. And I won't go too deeply into Hyperledger. If you want to look it up, also bring ibuprofen for Hyperledger. All right. Finally, we get to hybrid blockchain. Sorry it took us so long. You know, it's the point of the topic, but I like to lead up a little bit. So what is hybrid blockchain? Hybrid blockchain is a mixture of private and public blockchain designs. It has the benefits of both private and public blockchain, very few of the disadvantages of both. Hybrid blockchain is generally, well, okay, so a few days ago there was an article in Forbes about how hybrid blockchain is the future. And I was like, great, you're pushing more people to my talk, wonderful, thanks. So hybrid blockchain basically encapsulates the model of trust but verify. The idea that I want you to be able to take my information and work on it in a private environment, but then I can verify what you've been doing with that information. I can verify that you've got that information. I can verify what's being done with the information. That's fundamentally the idea. So it takes some of those trust concerns that exist with private blockchain, and it doesn't completely ameliorate them, but it assists them. So you're able to say, I have a verification stage whereby I can be sure that what's going on with this is actually going on. And that's very, very important. There is selective data exposure within hybrid blockchain. So because it's hybrid, you can take information to your private blockchain and you can expose only the information that you feel is appropriate at whatever time, whichever is appropriate for your business logic. I'll mention some examples later in the talk, but it's useful. You can also, with hybrid blockchain, piggyback on public proof of work on public blockchains. So the simplest, clearest example I can think of for that is you can run a private blockchain that is taking in data, generating its own blockchain, generating hashes for that blockchain data. And while it's all private, you're not really sure, no one from the outside is really sure that it's there. However, it is entirely possible to take the hash of those chains on a regular basis and submit them out to public blockchain. So you can add note fields to transactions in Bitcoin and Ethereum. You can take a hash of your chain at any given point in a private blockchain implementation and push that out to public blockchain. Now, one of the values of public blockchain is that everyone shares the information. The proof of work helps secure the process. Everyone shares the information. When I make that information about what's going on in my private blockchain public, I can no longer falsify that information. I can't say, oh, I didn't say that. I can't say, oh, it had a different hash. Nope, it's out there. Everyone knows it, right? If I were to tell everyone here that, oh, I have $20 in my wallet right now, and then later in the talk I were to say I have $30 in my wallet, everyone would go, you said you had $20 in your wallet, right? So even though it's private information, I can selectively choose to share that information. And when that information is made public, then the public network can be used to verify the information that I shared at that point. Very, very valuable. Now, one of the other bits about hybrid blockchain is that eventual consistency goes to eventual proof of validity. It's the same idea that I'm taking the information that's being provided, and in both private and public blockchains, as we talked about earlier, there's an eventual consistency idea. The transactions I present to the network are eventually constructed into a block. They're put on the blockchain. They're not immediate. They're eventually there. So what you get with hybrid blockchain is you get an eventual proof of validity. So eventually, as that block gets out there, there's a hash for that block. You can take that block, take the hash for that block, put it onto public blockchain, and then you get the proof of the validity of that data that exists. It's a very, very useful thing. That eventual proof of validity is one of the major changes between private blockchain and hybrid blockchain, because you get to have that proof of validity. It's not immediate, it's deferred. It can go through business logic processes. You can identify what you want to validate, what you don't want to validate, potentially, or you can say, I'm going to validate everything on this. Totally okay. So hybrid blockchain is really all about identifying the business logic processes that you want to model and basically being able to put them in place and have the security of public blockchain within your own private model. All right. So I figured I'd give a few examples of public versus private versus hybrid blockchain. So one that I use reasonably commonly is the idea of equipment maintenance records. So let's say you run a hospital. Some of you might run hospitals, I don't know. So you have equipment that needs maintenance. You have CAT scans, you have X-ray machines, you have ultrasound machines, etc. These things don't maintain themselves. They need maintenance. So records of that maintenance have to be kept. So you wouldn't necessarily want to keep those records on public blockchain, right? About on this date, a technician came in and serviced this X-ray machine. If, for example, your X-ray machine is getting serviced 10 times in a year, that might not look great to people, right? So on the other hand, private blockchain, purely private blockchain for this information, sort of maps to what's being done currently, where there's internal records being kept within hospitals for these maintenance processes, but it doesn't provide what you'd like to be some visibility. Because eventually, if I'm going to go to a hospital and I'm going to get an X-ray done, I'd like to be able to look at a public record that says that this X-ray machine has been validated by an approved professional, that it is working within specification and it's not going to kill me. I'd really like that. That'd be really, really nice. So the benefit of hybrid blockchain is you can take the records for the maintenance that's going on for these things. This can be kept in a private environment where if regulators come and they say, we need to see the information about this, we need to make sure they haven't been falsified, you've got the information right there about the maintenance that's there. But there's information about, okay, this machine was serviced 10 times, and at the end of this, a technician came in and he validated that it's working within proper parameters. That may be a piece of information that you may want to publish to public blockchain. So there's a real value to being able to use hybrid blockchain to consolidate those records. Instead of having two sets of records, I have my private set of records over here about maintenance, I have my public information here, if you can tie those things together and say, okay, the machine that we're talking about has the same ID, it's the same machine that was serviced on these dates, and now at this date, we can see that it was approved for use. Great, we get a lot of validity there. The only thing the public necessarily needs to see is that it's been approved for use. They don't necessarily need to see everything that goes on with the process. So private contracts. It's a great use case. So one example of a private contract would be my mortgage, for example. That's between me and my bank. Obviously, I don't want to put all of my mortgage information on public blockchain. I don't want really any of you knowing what my mortgage payment is. Nothing against you, but really, you don't need to know. So it's a private contract between two individuals. I want to keep that private. On the other hand, there are aspects of this that I need to have public from time to time. So for example, if I want to have maintenance done on my house, or if I want to have a new heating system installed in my house, the contractors who do that need to know that I am the owner of the house, that I'm not renting the house, that I'm actually the owner of the house, that I can actually show that I am the owner of the house. So in that way, the private contract, which I have with my bank, I would like to expose some information about that private contract to a third party, or ideally be able to refer them to a public blockchain reference that says, okay, Paul Sonier is the owner of this house at this location. That's useful information. We've all seen this happen before, where you have to provide a utility bill, for example, for these things. Everyone it's incredibly annoying. And there's information there that you don't necessarily, okay, you want to know that I live there so I can register for whatever. Do you really need to know how much I paid for electricity that month? No, you don't. Do I black it all out and provide it to you? That's awkward. So there's some information that we want to provide about private contracts that we actually want to make public. And the third example I wanted to bring up was proof of identity. So there is, so it's in the news currently about a lot of information was leaked by Facebook to third parties, and they've used it poorly. There's a lot of desire to do things like say, okay, here I am, I have this information, this is me, here's some information about myself. Again, a standard way that we do this is, let's say I go for a drink and I get carded. Doesn't happen that much recently, thanks to the gray in the beard, but hey, it used to happen a lot. And you provide your driver's license to the bartender to say, yes, I'm of age. The only thing you really want to provide at that point is that you're of age. You don't necessarily want the bartender to know what your home address is, or what your blood type is, for heaven's sake. Why do they need to know that? Why do I need to provide them with information that provides that? So by using private blockchain, that information would be kept completely private. You couldn't share it. By using public blockchain, everyone could see it, and everyone could go, oh my God, he's AB positive, whatever. But by using a hybrid of that data, where we have the private data that we're selectively exposing some information publicly to potentially a certain approved audience, then we get the ability to keep the information we want private and keep the information we want public. We really can't do that with either private or public blockchain solutions. It has to be hybrid. Okay. Sorry. Coffee good. Use cases. So, for blockchain security and data privacy. So, if I want to run a private blockchain and I want to keep it secure, keep all my information in-house, share nothing necessarily about the content of that information, but I want to make sure that that information is as secure from being changed as, for example, public blockchain networks. So there's sites you can go to that can analyze how much it would cost to, for example, falsify information on the Bitcoin network. Bitcoin uses proof of work that's fundamentally dependent upon the usage of electricity to run the ASICs to get the hash. That electricity is not free, and so it costs a lot of money. You can basically say, okay, if I go 100 blocks on Bitcoin and there's a transaction there I wanted to falsify, how much work would I have to put into, how much money would I have to put into falsifying the data on the Bitcoin network to basically regenerate the hashes for it to be, all right, I've now falsified this. It's a lot of money. It's a lot of money, I'll put that out there. Normally, with private blockchain, you can't get that level of validation and verification. But by checkpointing the hash data out to, for example, Bitcoin or Ethereum, any of the widely used proof of work networks, you get that data being public, and it's equally safe to any falsification avoidance that's there, and then you basically get that value of the security that's there, that the hash that I put there is out there. Everyone knows it. It can't be falsified at that point. Another use case of hybrid blockchain is to be able to change your business logic. I mentioned that Ethereum and Solidity are annoying because on the Ethereum network, any code deployed is immutable. Seriously, that is incredibly annoying. I will bring up, again, the Parity guys know this really well because they wrote the Parity multi-signature wallet. And as I'm sure everyone's probably familiar with, there was a small, just little tiny, itty-bitty bug in their code that led to their library code that validated any multiple signatures to be basically deleted. Their library code was deleted. They couldn't change the code, even though it was pointed out to them that, hey, you have this little problem out there. They couldn't change it, so the library code got deleted, and it orphaned a lot, a lot of cryptocurrency. And it was mostly their cryptocurrency, so, it's kind of a caveat, whatever. But the point being that the fact that that code can't be changed, if the code was able to be changed, they could change the code of their existing contracts that their wallets are subscribed to make sure that it was dependent upon a new library, which didn't have the bugs, which didn't have those problems, but they can't do it. They can't make those changes. And so that currency remains orphaned. With hybrid blockchain, because you're running in a private blockchain instance, you have the ability to change your business logic as you want. And so you can say, oh, there's a bug in that code. I'd like to change that. As someone who's developed software over a long period of time, I can tell you this. There is almost no software of any reasonable complexity that has no bugs. It's almost completely unheard of. And when you talk about revising library versions, revising standards, bugs creep in. Bugs are pretty much inevitable in software. And so having the ability to change your software in response to any potential defects that are found, and in addition to being able to change in accordance with the needs of your business, as your business logic changes, as your business model changes, the ability to change your business logic for that is very useful. I can also safely say that over the course of 5 or 10 years, the focus and direction of businesses will most likely change, and the focus and direction of their business logic they want to implement changes. To have everything that's tied to what they do be immutable and unchangeable is problematic. I will mention one of the solutions for this sort of thing is in the case of Ethereum and ERC20 tokens in particular, the quick solution that a lot of folks use is simplicity. They just don't go with any complexity. They go with, let's go with the simplest thing humanly possible, which is great. It means you're basically reducing your potential bugs, but the problem is it means you can't build in a lot of potentially interesting business logic into some of the smart contracts you might like to have. And so there's a lot of missed opportunities there. Okay, business logic privacy. I don't think I need to mention why that's important. You don't want to, let everyone know what the core of your business logic is if you have an important business. There are some businesses that are totally okay with being totally open about here's what our business logic does and here's how this does that. But for most for-profit businesses who have to work against competitors and make sure that they're keeping their processes safe and internal, they want to keep their business logic private. You can't do that with public blockchain. You can with private blockchain, but again, you get the issues of it's all sort of isolated. Selective data extraction, we covered that earlier. The idea that I might want to let you know my age, but not my address, or I might want to let you know what my blood type is, but not my age. I might want to let you know that I am the owner of this house, but not necessarily what my payments are for it. All of these types of things, very useful for hybrid blockchain and tough to do otherwise. And data aggregation and obfuscation is a useful thing. When we think about, this one comes to mind again when thinking about the Facebook data breaches. The ability to say, I want to put my data into this platform, but I want my data to not be used in any other form than in an aggregate form. So maybe to go back into the ages, so what are the average of all of my friends' ages, for example, on a social networking situation? Which is not necessarily leaking any information about any individual's age, but it is information about everyone's average age. That becomes useful. I think we can all see where it gets useful in the social networking situation. Sorry. So I've covered some of these before, but some of the distinct opportunities for hybrid blockchain lie within security. So I mentioned we get proof of work level security. So the ability to say we have thousands of Bitcoin miners expending this much money on making sure that their network is safe and secure and that they're capturing these transactions. They're expending millions of dollars. I think the numbers I saw recently were that it's something like the electricity usage of Denmark that goes into a block for Bitcoin, and that's not cheap. Even where electricity is cheap, it's still not cheap. So to have the ability to take the information that's on your private blockchain and just checkpoint it out. The cost for doing that is not the cost of what it would take to build a network that does all of that and provide all that proof of work. The cost is whatever the transaction cost is on Bitcoin for doing that. Or for Ethereum, it's whatever your transaction cost is to do that. It's very, very low comparatively. Multiple chain security. So if you want to take your hash of your blockchain data and you want to put it out there on, let's say, Bitcoin or Ethereum, let's say maybe you're not willing to bet the farm that Ethereum is going to be there for a while. There is nothing that says you can't put the same data on Bitcoin and on Ethereum. You can put it elsewhere, put it on as many chains as you want, as many chains as you have time and money to put it on. Then you get this really nice situation where you're increasing the amount of work even beyond what any of these chains could do individually. So you get an even higher level of security in that hash than even the best in class can do. So by putting the hash of your data on both Ethereum, for example, and Bitcoin, you even get a better level of security that that data will not be falsified than you would just putting it on Bitcoin, which is very high as it is anyway. Yes. So hybrid blockchain gives you reduced transactional vulnerability. So in the case of public blockchain, there are outstanding concerns with if you want to put forth a transaction, let's say during a critical time, something has to happen at this date. I have to pay my mortgage on blockchain, whatever. And it has to happen by this time. There is a vulnerability that exists with public blockchain, particularly because the contracts are public, that someone could say, I see that Paul has got to put a transaction out there at this specific time. I'm going to flood the network. I'm going to flood it and make sure their transactions don't go through. They may be small transactions, but if they price them appropriately high enough, they can flood the network. My transaction might not go through. There are cases where that's led to loss of, you name it. It's a potential problem. Hybrid blockchain, because you're basically keeping the business logic private, so it's harder for anyone to know exactly what that timing needs to be, because you're able to effectively scale it cleanly, then you can prevent any concerns with that. It's kind of nice. Efficiency. So I mentioned off-chain resources are hard to interact with in public blockchain. So with hybrid blockchain, you can get really simple interaction with off-chain resources. So the usage of oracles in Ethereum, for example. So if I want to set a smart contract that's going to do something if, say, IBM stock price goes to a certain level. On Ethereum, I can't check IBM stock price because I don't have access to it. I have to have something that will basically put the price of IBM onto the Ethereum blockchain, at which point then my smart contract can interact with that to do something with it. It's difficult. With hybrid blockchain, you can get the ability for the public functionality to go on there, but you can also interact with private resources. So you can just say, okay, hey NASDAQ, what's IBM's price, or whatever. And very simple, very straightforward. And you can still end up having a transaction that results on public blockchain for these things. Complex functionality. I mentioned the machine learning. There's all types of complex functionality that you may want to do in hybrid blockchain that you just can't really do the complexity in private blockchain, and that again goes back to the efficiency problem with private blockchain or public blockchain. Public blockchain is just not that efficient. Private blockchain is much more efficient, so you can do much more complex things to effectively an unbounded realm. And again, this gets really useful when you do very complex functionality that has potentially simple outputs. Machine learning is really good on this one because for machine learning, typically when you're training your machine learning network, it's a very complex and slow process. Using it, on the other hand, is actually a very fast process. So a validation against a neural network is a very speedy thing. And in fact, neural networks themselves are actually small data sets. So it would be entirely possible, for example, if you wanted to, let's say, have a smart contract that looked for potential fraudulent activity and was able to flag that fraudulent activity, be able to say, okay, I want to use machine learning to do this. Very hard to do that on public blockchain. If, on the other hand, you wanted to do that on a hybrid blockchain, and then basically have the hybrid blockchain identifying and doing the machine learning there, and then taking the result of that machine learning, pushing that back out to public blockchain for validation of any transactions that come through, perfectly viable, no problem. Oh yes, and on efficiency, lower transaction costs. That's just, for when you're running in a private blockchain environment, particularly when you're checkpointing out to public blockchain, your transaction costs are just lower because you're not effectively having to pay for everyone doing everything. You can pay effectively commodity compute prices plus whatever your cost is to checkpoint out to public blockchain, and that's generally much lower and much less variable than what public blockchain transaction costs are. Anyone who survived the CryptoKitties thing knows what I'm talking about. The high volume led to increased gas prices, and transactions were just nuts. Also, just the variability of ether prices can cause transaction costs to go stratospheric relatively quickly. So When you don't have to deal with that, when you're looking at, okay, here's just what our commodity computing costs are, it's straightforward. It's simple. It's more easy to predict. And therefore, when it's more easy to predict, it's more easy to get upper management to commit to, oh, okay, we're willing to pay this price as opposed to we're willing to pay this price that might go up by 1,000 times or might go down. That's just a tough sell. And mutability. So I mentioned earlier the ability to change your business logic in private blockchain. But one thing that's worth noting about that, and really if I keep harping on this, it's because Solidity is just driving me nuts. One thing about this is that the ability to change your business logic, but to have verifiability. So an example of this in the modern case would be, I want to make sure that the signature of the Docker container that's running my components matches my expected signature of my Docker container. And that's how I can verify that what's running in my environments is right. So it's a Docker case, but let's say you want to have business logic that is running your private blockchain. But you want to be able to change that, but you want your customers to have trust that you're not willy-nilly changing it and making everything all messed up. And your next change is, I'm going to take all of your public information, all of your private information and make it public. So what you can do with that is you can assure that your business logic that's executing on these things is basically hashed and identified out to public blockchain, and that any changes go through a process whereby they're validated by a trusted third party who can then say, yes, that code is approved, that code is good. And so you can mutate your business logic in accordance with any rules that your customers or clients may be in agreement with, and have verification that is out there on public blockchain that what you're changing about the way you're processing your business logic, the business logic that you're engaging in, you can have verification that that meets the standards that your clients have agreed with. That's really, really valuable. And again, you really can't do that with private blockchain. With private blockchain, there's kind of nothing that keeps you from going, I'm just going to change it, I'm going to change your privacy settings today to make sure that I can sell everything that I have about you. You can't really do that. When you're able to say, my business logic has been validated by a trusted third party, I don't know, Arthur Anderson, somebody, trusted third party. They're putting their assurance on this, and the code that I'm running is verified by, again, a third party to be in accordance with this hashed code that was verified by this trusted third party, perhaps a different trusted third party, then you get that level of validity, that level of trust. That's just not possible with standard private blockchain implementations. And in fact, that's sort of a brand new set of functionality that you wouldn't get with a standard private business logic implementation anyway. There's always this aspect of trust of, well, I really hope my bank doesn't decide to take more money out of my account than they should have. I don't have verification that they're not going to do that. And frankly, anyone who's been on the receiving end of a banking error, they do that from time to time. So, let's go next slide. So, eventual consistency. I mentioned this earlier. It comes up again and again. It's important. So, in traditional databases, the CAP theorem is very strong. The CAP theorem basically states that for a distributed database, between consistency, availability, and partition tolerance, you can have two, only two. CAP theorem is really important for understanding modern databases and modern distributed databases in particular. If you consider that effectively blockchain and public blockchain is a distributed database, then CAP theorem becomes important to understand in this case. Consistency is the main key here. So there's eventual consistency versus immediate consistency. Immediate consistency is I give you $10 out of my bank account. The next microsecond you come in and you check my bank account and it's got $10 less than it did before. That is immediate consistency. Eventual consistency is I write you a check for $10. And then you come in immediately and you go, oh, no, that doesn't reflect the check that he just gave me. When you deposit the check, then eventually it reflects that. So public blockchain always provides eventual consistency. You always get to a point where the transactions that are on the public blockchain are consistent. Eventually. It's not immediate. So in the first short-term case, so if I put a transaction out there, so Ethereum's block times are in the range of about 15 seconds. If I put a transaction out there for presentation on the Ethereum blockchain, it says I'm going to give an ether to somebody. That transaction won't be reflected in my balance until that transaction is incorporated into a block, and that block is published on the network and everyone gets it. So there's about a 15-second minimum lag there. Now, there's the problem that that consistency may not involve confirmation always. So the confirmation that you initially get is a new block has been mined that has confirmation of that, but there is an outstanding problem that the miner who mined your block may be mining closer to you, and they may have an orphaned mined block. There may be another miner on the other side of the network, far away from you, that has mined a different block that did not include your transaction, that the network will eventually come to accordance. But if they have basically more of the network that's going to agree with what they say, then eventually the network will end up with a consistent state that doesn't include your transaction. You can resubmit your transaction, you'll get there eventually, but the confirmation is there. So the public blockchain provides eventual confirmation in the block plus X. After some number of blocks, you can generally assume that your transaction has been confirmed and is complete and appropriate. What that number of blocks is varies a little bit. On Ethereum, 5 is usually pretty solid, but your mileage may vary. The idea, though, that it's not immediate. Even with public blockchain, you're not getting immediate confirmation, you're not getting immediate consistency on your accounts, and you achieve eventual consistency, but it's reasonably slow. Hybrid blockchain, on the other hand, can provide some immediate consistency. So there could be some aspect, because you're running in private blockchain, since you have access to external resources, those external resources can include some of the other proposed transactions into the block. And so you can actually get in a situation with hybrid blockchain where you're able to provide immediate consistency for that data, for those transactions. So you can say, that transaction doesn't need to wait for another block to be mined. I can validate right now that that transaction is not going to be valid. It's a very useful thing. It's a very, very useful thing. Immediacy versus eventuality. From a business logic perspective, it gets very, very valuable. And hybrid blockchain can provide the same eventual confirmation that public blockchain can by doing the checkpointing. So you can say, okay, you committed this transaction. It's on a blockchain. So eventually, I'm going to take this data, I'm going to confirm it, go multiple levels. This is a reference to Dragonchain, if anyone's familiar with the process, but doesn't necessarily need to be. And then eventually, that data can get checkpointed out to public blockchain. And there's that eventual confirmation that that transaction and the hashed set of blocks that leads up to it and that includes it is out there, and you have confirmation that it's occurred. Question? Oh, okay. No worries. Next slide, please. All right. Dragonchain and hybrid blockchain. Thought you'd never get it here, did we? So the Dragonchain model is private or hybrid. So You can operate Dragonchain in a model whereby your data is private and you never checkpoint out to public. It's up to you, whatever you want to do. By default, we support the ability to eventually go out to hybrid, and we support the ability to eventually go out to public blockchain. We're still working on some of these things, so give us time, but it is fundamentally in our model. As mentioned, it's hybrid by design, but it's not required. Our public chain interaction occurs at level 5 on the Dragonchain model. So you'll go through level 1 for your individual transactions. That's basically the private blockchain process. And then the transactions go up 2, 3, 4, and when they get to 5, they eventually get checkpointed out to public blockchain. And like I say, if you don't want to do that checkpointing out to public blockchain, there's nothing that forces you to, but it's available. And because it's available, we are the easiest on-ramp to hybrid blockchain. And I will readily admit, I am biased. I work for Dragonchain. I think we're the easiest way to get there. But even if I didn't, I'd still think it was pretty much the easiest way to do it, because it's fundamentally built into our model. It's fundamentally structured there. The mechanisms by which the process occurs are pretty straightforward. And it's only if you choose to not use them that you won't get them. But again, you're free to not.